Good afternoon, everyone. I hope you guys had a good lunch and here for a good session this afternoon. Well, doesn't seem like quite. Are you guys having a good conference so far? Yes. Come on, you can be a little louder. Are you guys having a real good conference right now? Yes. That's the spirit. Thank you so much, guys. So, welcome to this session on real-time analytics at scale for the Internet of Things. Now, first of all, let me just do a little bit of housekeeping here. The session's going to be quite technical. If you're here for an introduction to any of those topics, probably you're at the wrong place, okay? We're going to dive into a lot of demos, and we will get into a little bit of depth into those demos as well, right? So please bear with us if things are getting a little out of control. Feel free to question any particular aspect that you want a little more clarity on. We're more than happy to have a more conversational kind of a session over here today, and we'd be happy to answer questions as they come. But as they come, it'd be really helpful if we could walk down to either of these microphones so that we can record those questions as well for the recordings, okay? Well, with that, let's just start off with a quick round of introduction over here. I think I'll let Asad introduce himself first.
Hi, I'm Asad Khan. I'm a principal program manager in the Azure Big Data team. So our team basically runs a Hadoop platform that comes with multiple components for building streaming and big data solutions.
Thanks, Asad, for joining us today. Guys, I'm Nishan Thakkar. I'm a technical product manager for the HD Insight product and the big data analytics services from Microsoft. So I work around all the beautiful decks that you see. I work around all the demos that you're seeing around on HD Insight as well. And I work on creating a lot of readiness material for customers and partners like yourselves, right? Well, before we go any further, I have a few good giveaways today, so be a little more interactive and you can stand to win a lot of things from us tonight.
See, okay? It's good to have someone from the marketing as your co-speaker. That's why I always tell Nishan, like, what are you doing? Like, let's go and present together. So,
well, ground rules. We're going to talk about a lot of technologies. At the end of the session, I'm going to ask you the names of all of those technologies that we mentioned during the session. And if somebody can answer all of those, well, there's a Sony $150 headphones right there for the taking, okay? Apart from that, we have a lot of T-shirts. We have a few USB drives as well to give away. So be with us and answer a lot of questions whenever we have any. With that, let's get into the session objectives and the key takeaways for today. Well, in today's session, we just want to go ahead and explain the implementation of a real-time solution. Now, as the title says, we're going to take the example of an IoT solution and drive through that. But in addition to that, we'd be kind of digressing a little bit to explain some concepts here and there. Okay? It's important for us to make sure that everybody in the audience goes out of this room today having a good understanding of how real-time solutions can be very impactful and effective with Microsoft Azure, and specifically the HD Insight service, the Storm, the HBase, the Power BI components in there, all of it. If all of you, or probably even 50% of you, can walk out of this room having the confidence that the Microsoft Azure platform is a considerably good platform for the implementation of such solutions, we'd consider our jobs done, okay? The agenda that we're going to follow today to drive through this discussion is very simple. First, we're going to talk about streaming data, okay? What's streaming? Why do we need it? What is Storm, okay? Then we're going to dive into low latency storage. Well, what is that? And exactly the answer to that particular question, okay? And then towards the end, we'll dive into bringing all of these pieces together to show you an end-to-end solution around real-time analytics. With that said, let's get Asad talking a little bit about streaming data now. Asad, all yours.
Okay, so thanks, Nishan. So as Nishan said, like basically the objective is that we will give you an introduction of some of the technologies that are used for building IoT streaming solutions, and then we will get into the demo. So the first question comes that what is streaming and why you need it? So there are many scenarios for which people go and use streaming, and there is a reason for there is so much talk these days where like the traditional tools did not work, and the new tools were introduced in order to go and build these solutions. So whether you go and talk about the IoT, and in this case, like we are already working with multiple companies, either the case is that like companies are going and installing these devices and they want real input streaming, and if there is a problem, they can go and even send a signal back. Or there is the case of like the connected cars where the car is sending a lot of data, or whether it is fraud detection analysis and all of that. So there is a lot of scenarios in which case the time to insight and taking an action based on the insight that you get is very, very important. Like recently we have been working with a retailer, even not in, they don't even have a website except for the physical store. Within an hour, they want to know what people are buying. And based on that, they can make changes in how they adjust the inventory or how do they position the inventory. So it is really amazing how these technologies have enabled people to go and build solutions which were not possible before. So in summary, basically, there are three key, let me actually come back to this one. Yep, so basically, what I want to start with is like a quick demo. This is the demo which actually I built last week at Build, but this will give you an idea of in terms of like what streaming is like and how you can go and do it. And similar, this is a very simple one. It uses the Twitter one, but it will give you a quick intro. So, and this is a public actually website. So if you want to go and you can also try it. Let me just. Okay, so the website is datadvr.com, and this is like if you are interested in seeing how you can go and build it, like we built it on stage at Build last week. But what it does is that it does two things. First of all, you can go and pick a topic and it analyzes all the tweets that are coming for that. So for example, if I say Game of Thrones and I say live, it will show me all the live tweets that are coming in. Again, not fun. You can go and do the same thing at going to the Twitter app. But at the same time, there's a lot of business logic. It gives you the opportunity to go and add. At the same time, you can go and use HBase, which we will talk later. And we use that technology to go and store all the tweets that are coming in. And then basically, we were able to build the Twitter DVR. So for example, if you say that the last show was, when was the last show of Game of Thrones? Let's say it was on May 3rd. So if I go say May 3rd, and then I say it streams at like 6 p.m., then I don't need the live. I can go and play. At that point, what it does is it simulates as if right now it is that time, and it will show you all the tweets that were coming at that time. So the concept was that someone who records the shows and watches us later, but at the same time they want to go and see what is going on Twitter, they can go and basically sync the time of the show as well as the tweets are coming. So again, this was a very simple app. It is hard unless we have a full fire hose access to the Twitter. It doesn't even justify the big data app. But it gives you an idea in terms of like how easily you can go and connect to these real-time APIs and build apps on top of it. So what we will go and do is actually build an IoT app in next 50 or so minutes. Before that, let me introduce a few concepts which will help you. So as Nishant pointed out, Storm is used for building streaming solutions. Apache Storm is an open source project. Microsoft make it available as a fully,
managed
service. Fully managed service on HD Insight. What that means is that you can go and easily go and deploy as big of a cluster as you want, and we also provide you as an SLA of 99.9% uptime. So you don't have to go and worry about it. Because if in the open source technology, the biggest problem is whether you can trust the quality of the product, if there is something wrong, who do you call, and all of that. And that is what Microsoft brings in, because Microsoft, most of their customers are big enterprise customers. So the key thing to notice in this one is the pipeline. In the typical streaming solution, what happens is the data is coming in from one side, and that could be any data. This is your data. And then from there on, you get into some sort of queuing service, and then you put Storm, which build the Storm topology. That's a term which is used. And the three terms we will use a lot is the topology that you build, and it is made of spouts and bolts. So spout is a data connector. That is the one which actually reads the data, and bolt is the one where you actually do the operation. And then you can do multiple things with it. You can push it directly to your live dashboard, or you can go and store it for trend analysis or deeper data analysis. So this is the very quick intro of the technology itself. And as we get to the demo, I will call out the things that are new concepts. The demo we will build, it goes next, is this one. Basically, what we will do is that we will actually go and take data. We will go and push it into the Event Hub. And from there, we get the data out. And the scenario in this case is, let's say I have devices. And the devices could be different categories. I have UPS installed. I have heaters, coolers, all around the world or in US. And they keep sending me signals. As those signals come in, I will go and analyze what is the temperature of one of the component in that equipment. And based on that, I will go and see if anyone is overheating and how I can go and take the action. So the way the pipeline looks like is that you get the data into the cloud, and then you pull the data, then you get the reference data. Why the reference data is needed? Because like that device doesn't know what is the threshold. So there is a lot of data that is already there is like data which is about like when this device was installed, what is the threshold, and all of that information. Then there is a lot of business logic that we can go and write. Then after that, we take the raw data and store it in a NoSQL. And then we take the same data and we push it to the live dashboard, as well as we put it in a relational store like SQL Server for report building. So this is the example, and in this case, if you want to go and take action, you can push the data back into the queuing service and back to the device. Is it a good one? Like, okay, so let's get started. So it requires a lot of setup. What I have done is that I have built template for every setup that I'm doing. So anyone who wants to go and follow the demo, they can actually do it, other than sharing my own credentials, which was not a good idea. Everything else is actually online as templates. So you can go and follow the steps, and as long as you have Azure credentials or access, you should be able to build the demo as I go. So what I will do is that let me show you a few of the setups that was done before. So this is the Azure portal. Like, how many people have actually even seen Azure portal or worked with it? Okay, great. So this is the Azure portal. This is the new Ibiza portal. Some of the technologies are actually just available in the new Ibiza portal. So that's why I also brought this up. This is the dashboard for my DocumentDB. DocumentDB is a document store. It is like MongoDB. The way it helps is that you can go and store lots of documents in there, and then you can look up those documents based on a certain key. So in this case, what I have done is that I have 8,000 sensors, and for 8,000 sensors, I have a document for each of those sensors, which tells me that given their ID, what is this device? So this is like the ID is 102, it is a server, and the threshold temperature is 102. Similarly, like if the ID is 105, it is a cooler which I have installed, and the threshold temperature is 75. So basically, if the temperature of this device goes above 75, then it will alert me that there is something going on with that device. So similarly, these are like 8,000 documents sitting here. And what I have done is that if you go in the Visual Studio and you say new project, and if you go online and you search for Ignite, you will find the templates which I'm going to go and use for this thing. So you will also find if you go and search for the DocumentDB writer template, it will give you the template. You just go and run it, and it will actually feed it to DocumentDB and fill it with all the 8,000 documents. So that is one of the things which I ran beforehand for the setup. The other one which I have done is that I have the HBase and Storm data clusters that I will go and use for building my demo. Okay, so let's get started. So let me quickly go over here and show you one thing. So the first thing which I will go and do is I have the data sitting in the queuing service. From that, I will go and start reading the data. And the way I read it is like I use Storm, and I add a spout, which, as I said, is the data connector, and it will start reading all the events that are coming real time. And from there on, then I will add a DocumentDB bolt, which is, again, bolt is the code piece of code where you add your action item. And then you can join the two and figure out this is the data which is coming in, this is the temperature at given point, and what is the threshold. And if it is the threshold is more, then I highlight that this there is a potential that this device will fail. So if you go, so I have already, as I mentioned, I have already deployed the one which pushes the data in the Event Hub. And since I'm using Visual Studio with the Azure SDK, on the left you will see that I have all my clusters listed over here. And as it refreshes, it will show me the Storm clusters that I will go and use. So the first thing I will do is I will start new project. In the online gallery, I will search for Ignite. In the Ignite, it shows me the IoT starter template. I will go and use that one. And this gives me the scaffolding for building my streaming solution. And if you go and look at it, all it has is it has an event class, which gives me just the class to hold the device ID, the equipment category, zip code, and temperature. And it has the topology. And if you remember, topology was the one which I was mentioning here. This entire thing is the topology. So I will go and slowly build one piece at a time. Right now, the topology, all it has is a connector to the Event Hub. Again, so as I said, like you have to put in your own credentials. I will go and use the snippet to give the credentials for my Event Hub. So I'm using the reader. This is the key. And then this is the name of the Event Hub cluster. And now it will go and connect to it and start getting the stream. So if I go and build at this point, it will go and get all the dependencies, and then I can go and deploy this thing, and it will start reading. But again, it is not that much fun, so I will add few more steps before I go and deploy it. But at this point, if you go to the Storm cluster and see the topologies that are running, there is only one, which is the one which I deployed ahead of time, which just produces the events and actually pushes it into the Event Hub. So a couple of points to note here. The first is that Storm is an open source technology. The primary language which people go and use it is Java. So what Microsoft did is that they enabled the .NET support for Storm. That itself is a huge step forward, because most of the customers we talk, they prefer .NET. But they still want to go and use the technologies which are built in the open source community. So with this, you get the full .NET support. The second thing is integration into the tools we are all familiar with. So in this case, for example, the Visual Studio. So as you can see, I can go and build my project, and in this case, the topologies. I can use the tooling. I can go and deploy it into the cluster, and I can also monitor. So as you can see, there is already 322 million events that I have written to the Event Hub. That is the only random generated data I have. In actual case, this data will actually be coming from your device. But from there on, everything which I build is as if you are building your real-time application. So what I will do is that the first step I will go and do is I will go and get the reference data from the DocumentDB. So in order to do that, what I have done is that, again, this is a template which is online. So if you go and search and say new item and you search for Ignite, there will be one which says the DocDB reader Bolt. Again, as I said, Bolt is the one where these are the standalone components that you keep stitching in building your IoT application. And most of the code, like for Spouts and Bolts, is already available in the open source community. We have just made it easy to get through the VS. So I will say the DocDB Bolt. And this, let me quickly show you the code. What it does is basically it's a template template that allows me to go and use the DocumentDB.NET API, connect to it, and then get the data that I'm looking for. Again, the first thing it will ask is the credentials, so I will go and add the credentials for my DocDB. And this is the same one which I showed you here. This is the DocDB which I will go and connect, and then I will use the data which is coming in to join it with the data that is in the DocumentDB. So I will give the credentials for DocDB. So this is the credentials. I will save it. And so at this point, we have built the first two steps. We read the data from the Event Hub. Then we added the Bolt to go and get the data, reference data from the DocumentDB. The next step that we will go and do is that we will go and add a business logic. And again, in this case, the business logic is pretty straightforward. What it does is that it looks at the data that is coming in. It looks at the reference for the entry for that device. And if the temperature is higher, then it just says that the device has failed as a Boolean or a 0 and 1. So again, I go there, add new item. And in this case, what I have is the business logic Bolt. And again, in this case, there is no credentials required. All it does is that it says that if the data is more than the threshold, then it flips it to 1, otherwise it keeps it as 0. So now the last one I will do is, before I deploy it, is I will, before I even store it in SQL or in the or in HBase, I will just push it to a live dashboard. The live dashboard I will go and use is Power BI. So the way I set it up is like literally you go to Power BI and you provide your email address and it will create an empty dashboard for you that you can use for multiple reasons, for building reports, for real-time analytics, dashboarding, and everything which is in the BI space. So I will go here and say add a Bolt for pushing it to the Power BI. So I add this, and again, the Power BI uses the OAuth mechanism to make sure that it knows my credentials, and this app has can go and write to that the Power BI dashboard. So that information is captured in this over here. So I will go and replace it with the actual credentials for my client and username and password. So I will store that. Now my pipeline is ready. Now it is going and reading the 300 million messages that are sitting in the Event Hub. It is getting the reference data for those and saying like what is the threshold for this given IoT device. Then it will go and do the business logic. In this case, it is just comparing. And then it will go and push it to the live dashboard. So if it all works, hopefully you will see like the number of devices that are failing and which one are failing. Before I do that, the one thing which I will go is that you have to wire these up because I'm just adding these new classes. So at some point you have to say where the data is coming and who is giving it to what. And then again, that is the deeper concepts in Storm. But the way you do it is you build your topology. So you have your bolts and spouts, and then you stitch them together. The way I will do it here is I will go and add the snippet that says add the DocDB bolt. Then it will go and the second one which I added was the business logic bolt. And the third one which I added was, and I will go through the code in a minute. The Power BI. So let me make it a little bigger. So the way you do it is like when you set a bolt, the information it needs is that what is the name of that bolt. Then it says that what is the output schema. So in this case, as I was telling you, the schema is that all my 300 million devices are sending me the device ID. They are sending me what is their category. They are sending me the zip code. They are sending the temperature, the threshold, and whether it failed or not. So with this thing, let me make sure I added all the information in here. So I have the DocumentDB bolt, I have the business logic bolt, and in the end I have the Power BI bolt. So let me go and build this thing. And then I go and say deploy. And I give the Java path, and let me explain you in a bit why I need the address to this jar file. So again, as I mentioned, Storm is an open source technology. Most of the people who go and write these pipelines for streaming write it in Java. So there is a big ecosystem of spouts and bolts that are available out there. In our case, when we moved and enabled .NET, the problem was that you either go and create all those samples in .NET, otherwise you will never be able to catch up with the open source community. So what we enabled is a mixed topology feature. What it does is that you can go and add your spouts and bolts in Java, but then you can add your custom ones in .NET, and then you can still stitch them together. So in this case, the reference that I gave was for the Java library that is used to go and read the data off of the Event Hub, which is the queuing service available on Azure. So that enabled us to go and use any of the functions that are available out there and all the connectors which are called spouts out there to go and use those, but still stitch them together with my own business logic, which is written in .NET. So at this point, it will go and, as you said, see it compiled it. Now it is submitting the topology. So literally, it is taking all this code that I just added, and it is connecting to my Storm cluster, which is over here, which already has one topology running, which is the writer. And it will deploy that, and it will start running. And when it starts running, basically it will start reading data off of the Event Hub, which is the queuing service, and it will go through the pipeline which I have added. So basically reading the document DB, doing the join, adding the business logic in there, and all of it. So
let's take a step back over here, Asad. So how does this happen in a normal Hadoop environment? Do we have these kind of capabilities in, let's say, any of the on-premises Hadoop capabilities as well? Can they come into something like a Visual Studio, right-click on a solution and go say deploy, and the entire topology with all of its dependencies gets deployed on the Hadoop cluster?
So it's a good question. Basically, in HD Insight, what we run is the distro of Hortonworks, which is also available on-prem. But most of the additions that you see here, for example, making the cluster fully managed so that we provide an SLA, the full developer environment, and the productivity in VS, those things are not available on-prem. So if you go on-prem, you can go and still deploy Hadoop and Storm and HBase, but you will have to go and
RDP into the head node, take all your files, create a jar, take all dependencies, copy it over there, and then run command line tools to go ahead and deploy even something as simple as a topology.
Right. Again, like some of the innovation, of course, has been done over there as well, because again, if you are on Linux, you can use SSH tunneling and other stuff. But again, like the environment will be very, very different, especially for the Microsoft client community.
Great.
So again, so in this case, it says, let me just refresh this thing. So it already shows the IoT over here. Let me just refresh this thing. So this is the IoT dashboard, which is where it is pushing the data. Some refresh issues going on.
That's all right. Okay, time for a quick question for the audience in the meantime. How many technologies has Assad already talked about in the Storm topology that he built? Like, can anybody name the number of or the services for which he created spouts or bolts? Anybody? Go ahead. No. Okay, one. Event Hubs, Power BI. 7? What were the 7? Awesome. That deserves a t-shirt. Here you go.
Okay. So,
Ashish.
huh?
Yeah, is the topology there?
Yep, the topology is here. So this is the reader topology that we deployed. As you can see, it has read 17,000 events so far, and these are the business bolt that we added. This is the Power BI bolt. This is the Document DB bolt. As soon as the BI website refreshes, you should be able to see the data that it is pushing it over here. Let's give it another try. Anyway, I will go and build the next step, and then we can go and come back over here. Let me kill this for now. What I will do is I will go to the next step, and hopefully the Power BI dashboard will come back. So what I will do is that I will go to the next step. In this case, what I will do is that I will go and take the same data and push it into the SQL Server, and that will enable me to go and build the reports. So we are already done with the get data. We have the reference data coming from the document DB. We have the business logic bolt. Then we push the data into the live streams. Now I will go and take the same data and push it into the SQL Server. So this is the SQL Server I created, and again, very simple. If you go and run the command, there is no data in here, which is the key and the device ID and the equipment category. I will go and add a bolt for SQL, and that will enable me to go and write it to the SQL Server. So coming over here, I have killed this topology for now. So I will close this. I will go here and add new item. In here, you will see under the Ignite, you will see the SQL Azure write bolt. I will take this one. I will add it here. Again, all it requires is my credentials for connecting to my SQL Server. So this is the name of the database. This is the table name, which I am using over here, which is IoT log table 1. And these are the name of the columns. I will go, and again, the last step, if you remember.
Table names probably incorrect back in the SQL and this one.
The IoT table 1?
Yeah, can you just go back, change? Yeah, that's IoT lot table.
Oh.
Yep. Can you just change it back to lots table there?
Thanks. Although it should be log, but I will. That is harder.
That's all right.
That is the harder. That is a harder one to make the change. So, so I will go build. The last step, if you remember, is I go to the topology. I will go and stitch it together. So again, what it says is that it takes the name, the get method. There is no output coming from here, and this is the input, and the input is coming from the business logic. So if you go and notice the way the topology is set up is that I have my DocumentDB bolt that is reading directly off the event hub. Then I have the business logic bolt, and it is reading from the DocumentDB bolt. Then next I have the Power BI bolt, which also reads from the business logic, and the Azure ones also read from the business logic. So let me build it again, and I will go and deploy this one. And I will pick the cluster. Let's say I've built this one, and I say submit. So again, going through the same process, it shows you the iterative process of building. What it does is that, again, packages the whole thing, pushes it into the Storm cluster, and start running my pipeline again. So again, it takes a few seconds because it goes and takes the entire project, packages it as a zip, and then uploads it to my cluster. But once it does it, basically you will see that now the same data is also being pushed into the SQL Server. Let me see if this works. So this is the one which we pushed earlier. So if I go and pick the equipment category, let's say, and let's say the count for failed. Oh, so we killed the topology, so that's why there is no real time. But once the topology is back running, because this was based on the previous push that I did, so as soon as I brought the topology down, it is not getting any more data. But if you wait for a second, and when the topology is back up and running, then you should be able to see. So let me just open it here to see the topologies. Right now, this is the only one, which is the writer one, which I showed you earlier. In a second, you will see the reader one, which is the one which is going and reading it. So, so now at this point, we have built everyone except the HBase. So let me introduce the technology of the HBase, and then we can come back to the demo. So HBase is, how many people actually know about HBase or have used it? Okay, great. So HBase is a NoSQL store, and the reason it is used is when you have really, really large data set and you want really low latency. So the example is, for example, Facebook uses HBase for all the messages that you get in your inbox. And if you look at the number of people who are at a given time going and reading and replying and updating, so it is a very fast, very low latency NoSQL database. And what it does is that it uses a schema, and then you can index it on a column. And if you scan it or search it for that indexed column, it returns you the result very, very fast. And in our case, as I was giving the example for the datadvr.com, what we were doing is we were putting all the millions and millions of tweets that are coming into the HBase. And then when you, in the drop-down, you go and filter and you say, oh, I want to go and see all the tweets that are coming for Game of Thrones or for Ignite or for Build. We use that index column to quickly search on it, and then we start showing all the results that are on that one. So the other advantage with HBase is that if you are using Hive or you want to go and do a deeper analysis, then you can also take the data which is in HBase, and through the interface called the Serde, you can go and create an externalized Hive table. And then it lets you to go and write the rich Hive queries that people go and do it. So it is a very, very common store which people go and use. If I'm doing reporting or something, then I will use SQL. But if it is like I have millions and billions and petabyte of data, I can go and use HBase, and that allows me to go and use this store with very low latency. So coming over here, let me see. So it shows you the reader topology over here, and let me see. At this point, I should be able to. Sorry, every time I switch to PowerPoint, I have to. Okay, coming back. So this was the writer topology, which is continuously writing events. This is the reader topology. This shows you the dashboard. In dashboard, it shows the number of events it has read so far since I deployed the new one. It talks about the spout, which is the connector, how many it has read. It talks about the bolts we have built so far. This is the first, DocumentDB is the first one which we used. It has emitted and read 820, then it gives you the business logic, then it emits, then it gives you the Power BI. And since Power BI is on the end, it's not sending it, although it is pushing the data to the website, but it is not sending it to any other bolt. So the emitted is 0. Similarly, the SQL one is writing to the SQL, but it is not sending to any other in the pipeline. So that one is 0. And if I go here, this is the dashboard. And if I go and pick the equipment category, and I say the number of ones which are failed, then it shows me how many have failed. I can go and save this file. So this is the category view. I can go and pin this thing to the dashboard. So if I go to this dashboard, this is the data. Sorry. This is the data which is coming in. And as you can see that as the more devices are failing, it is going and updating real time if more devices fail. So basically, that is one view. You can go and, of course, create other views. You can go and say that I want to create a view which just gives me the number of my failed devices. I can go and change it very quickly to a different view to go and see. So 89 devices have so far failed out of 8,000. I can go and again save this one. Total failed. I can go and pin this one to the dashboard. So now it is 97. As the more and more devices will fail, it will go and update this value. So now very quickly I have built the, you want to change something?
No, just want to pull the power cord. Yeah, thanks.
So very quickly, basically I have built a real-time dashboard. What it is doing is that it is taking the pipeline which is deployed here. It is continuously reading the data that is being thrown at the cloud of all the devices. It is taking the data and referencing it with the DocumentDB, which has the document. So every time someone goes in and installs a new device, that person writes a document as JSON and pushes it into my DocumentDB. So there is a record of every event, every device that I have put in the field. So I do a join. I say what are the safe limits, what are the specifications. Based on that, I build my business logic and I pushes it into this real-time dashboard. So again, as long as this is running, my dashboard is my real-time dashboard to get me a view of how the devices are doing. At the same time, if I go here and if I run the command now I can go and see all the data coming here as well. So it will show me that this is the ID, this is the equipment category, this is the zip code it is installed, and the way it helps me is that now I can go and use all the traditional tools that are used with the SQL. So I can go and refresh my data, and it gives me the data at that snapshot. Of course, this is not real time. Like the SQL is continuously being read, but Excel is not updating. It's a pull method, whereas the Power BI dashboarding is a push. Using the push mechanism, I can push updates But over here, what I can do is that for a given time, I can go and I can say insert, and I can say insert the power map. So I can create a new one. And let's say if I say based on my zip code, show me the devices which are being failed. And it should update. Let me just try one more time. Map, power map, let's create a new one. So it uses the zip code. And then let's try the
Ready plotting it.
Oh, okay. Let me give it a minute. So again, as you can see, that the number of devices so far are already more than 2,000. So that's why it's taking time. But when it plots, basically, it will give you for every zip location how many devices are failed so far. So coming back, so the only part which is left is the HBase one. Again, I can follow the same way. I can go and I can say add new one, and I can add new item. And in this case, I will say add the HBase writer bolt, which will go and write it to the HBase. And as I add it, basically it has the client APIs .NET to go and push the data into HBase. HBase is the one which I built ahead of time. So if I go to my all my clusters, I can go to my HBase cluster. I can go and even connect to this cluster, and it will show you the tables which are already there, and the new tables that it will go and create for the data which it will go and push. Again, the connectivity is some reason is not that good over here. Yeah. So again, as I said, like basically the last step, what I will do is that I will go and add it to the topology. In this case, I will go and add the HBase topology, and so now it has stitched together my entire one. Just the name mismatch. Let me see what is the class name I gave. So this is the HBase bolt. I will go and put the HBase bolt in here, and this one. So now if I go and build, I have built the entire pipeline, which was this one, which gets the data, reads the reference data, pushes it into the live dashboard, pushes it into the SQL server. And if I come here, like it shows you there are more than 2,000 events. If I go and rerun it, it will show me there are 3,000 events. I can go and build the reports. It's taking time to refresh this one. I can go and use the Power BI dashboard. So now it shows that so far 17 devices have failed. It shows me the category. I can go and build different type of things. I can go to my HBase one. Again, sorry, connectivity issues, but I can go to connect to my Insight one, and once it connects, I can show you the data which is being pushed over there. So let me quickly go to the slides. So HBase is the one which we covered. And so in summary, if you go and look at it, then in terms of the technologies which we use to go and build, like in 20, 25 minutes, a complete working topology for building your analyzing your streaming data that is coming from the IoT, from your devices, is that you have the devices, they push the data into the cloud. From there, you have the Storm topology. The Storm topologies read the data, get it from the reference data. You go and add your business logic. You store your raw data into both HBase and the schematized data into your SQL Server, and then you can push the data into your Power BI. Again, these are just examples, like you can go and replace these technologies with anything you want. And one of the things which these open source technologies gives you is the scale and the flexibility. As you saw, that DocumentDB is not part of the HG Insight offering, but all I needed was go and write a class that uses their client API to go and push the data. Similarly, I can go and keep stitching that together. The key thing to keep in mind is that this code, which I'm writing here, whether I'm using it for 100 devices or for millions devices and the data is petabyte, the key thing is that you don't have to go and refactor or write your code in a different way. What Hadoop and Big Data Solutions gives you is the guarantee that it will keep working, and you can go and scale your clusters up and down. So if I go, for example, back to my Azure, so if I go back to my Azure portal, and if I look at one of the clusters that I was using for the Storm, and you can go to the scale, you can see that it is a very small cluster. What I'm using is just a 4-node. If I want, and if I am getting too much latency in my processing time, what I can do is, like, I can drag it over here all the way to as much the size of the nodes, the size of the cluster which I want. So if I go and save at this point, what it will do is that it will create this 4-node cluster into a 63-node cluster. And if you already had a topology that was running, there will be zero impact to that topology. So the key thing is that Hadoop provides you the fault tolerance, it gives you the scalability, it gives you the guarantee of the processing of the data, and these are the assets. Otherwise, like for most part, like what I showed you, someone can say, oh, I can go and write the whole thing in a single class in a .NET, because all you were doing is, like, you are just reading the data and doing some processing. The key thing is that once you get to the scale of really, really large data, the same code base should scale to those problems, and it gives you the fault tolerance. So the last thing I would add would be that what we have done is that we have built all those end-to-end samples which I showed you. So if you go and go to this website and download that thing, the first one which you will see is the IoT example that uses the same example that I'm using, but it generates 1.5 million messages per second. So if you go and run this thing, and the thing which we have done is that we have packaged it as a PowerShell script. So all you have to do is say run all, and as long as you have the credentials for your Azure subscription, the first thing it will go and do it is, like, it will start generating 1.5 million messages automatically. Then it will take your subscription and create an event hub for you. Then it will use your subscription to create a DocumentDB for you. It will, again, create a Storm cluster for you. And then it will start emitting all those messages and processing it. And there is a HTML page that shows you the number of events that you are processing per second. And again, like with 32 partitions, which is the default for Event Hub, it will give you 500,000 messages processed per second, but you can request for 128 partitions, and then it will go to 1.5 million messages per second. So again, that shows you the scale, the flexibility, and the guarantee that these open source technologies gives. Again, like, sorry, it took too much code and all of that. Hopefully it was useful. So again, Nishant works with our customers, and as he was saying, like, he built the awesome demos. So what he has done is that taken pretty much the same pipeline, and actually shown in how in production these systems look like. Okay.
Right. I think we can switch to my screen now. But before we get any further, I see a few sleepy eyes over here. So let's wake them up a little bit. A few more quizzy questions. Who can define what a spout is? He's been defining spouts a lot of time. Who can come up with a good definition for a spout for me? Awesome. Here you go. All right. Another question up here. What can you do within a bolt in Storm? Come on. He's done a ton of things within a bolt in Storm. What all can you do in there? What's it meant for? Could you elaborate? Business logic. Who answered that one? Who was that? Not you. Not you. I'll give it to him. You should come and pick it up from here. All right. Well, let's dive into something that's a little more interesting now. He's been showing you the Visual Studio stuff all this while. And as Asad mentioned, I've tried to bring together all of the kind of pipeline that he created in the back end into life for a production scenario. And what we're going to talk about over here is a fleet management company. Now, a fleet management company does a lot of real-time analysis. They have a lot of trucks on the roads. They need to know how those trucks are doing. Those trucks carry a lot of freight. They need to make sure that the freight reaches their destinations safe and sound as well. So all of these fleet management agencies have a very rigid mechanism to go ahead and do some analysis on real time with those trucks. Now, how do they go about doing it? Well, they have very tiny sensors for various kinds of information within the truck. For example, the fuel gauge reading. For example, let's say a light sensor. For example, if it's a trailer which has a cooling unit, that's going to have a temperature sensor. For example, your tire pressures, all of those need sensors. And in addition to just doing real-time analysis, what these fleet management agencies can also do is do some preventive maintenance with the help of predictive technologies like Azure Machine Learning. Now, let's dive into one of such dashboards that we've been able to put up for a fleet management company. Now, whatever you look at on this particular page over here is basically a dashboard that would sit at the control unit of any of the fleet management agencies. In the map, you see the location of the various trucks in the region that are plying right now. On the left-hand side, you see a KPI summary. Now, that's actually coming in from a Bolt. What are we doing there? Well, we're performing some windowing operations within the bolts, trying to analyze various metrics that would be important to a fleet management company. Okay? Now, for example, how many drivers are currently being utilized? What's the fleet status right now? What's my on-delivery status right now? And all of that's coming in. Now, in addition to that, as I mentioned, each of these trucks actually contains freight. Now, this freight can be something that's dispensable, that could get spoiled very easily. In our case, we've actually got one of those trucks which contains fish, and specifically fish for sushi, which is very temperature sensitive. Okay? Now, let's go ahead and see what all information is being captured over here. And mind you, all of this has a storm cluster and an HBase cluster in the back end. So all the events from the trucks that you see on the map, and we've simulated data for about 42,000 of those trucks, all of that sensor data is actually going up via the cloud gateway onto the messaging queue called Event Hubs. And from Event Hubs, as Asad just demonstrated, we have a spout connecting back, pulling all of these events, trying to perform some calculations across those, like, okay, in the last 10 minutes, how many of those sensors are showing spikes? How many of those sensors are going down? How many of those sensors are showing me invalid values, etc.? Or how many of those drivers have actually parked their trucks for whatever reasons? And I can analyze all that information. In addition to that, from within the bolts, I am actually calling a machine learning model that has already been published. Now, what does that model do? That model analyzes the sensor events and the trends in those sensor events to give me a prediction for the next 4 hours as to what is going to happen. Now, that particular machine learning model also takes into account the weather information that I have for that region, the traffic information that I have for that region. Let's go ahead and see that on the map right now. If I just go click on the weather icon over here, I can actually go ahead and plot the weather on my map. And as I see, machine learning is predicting that the 3 trucks right at the bottom are actually running into a stormy region. Well, could that be a reason why they are showing up as red on the map? Absolutely yes. You would argue, why aren't the others? Well, it's taking into account the direction of the trucks as well. If they're going out of the stormy region, there's no reason for me to worry about. If they're getting into a stormy region, that's when I need to be worried about. Again, when I get into the traffic information, as I said, I'm tracking all the traffic information that's coming in from Bing on these roads. And all of this is being fed into my machine learning model to give me predictions as to whether my trucks are going to reach their destinations safe and sound, whether the freight contained in them is at danger, am I at a loss at any point in time, okay? Now let's actually go ahead and dive into one of these trucks. Again, all of this is actually real time. So if you notice over here, some of these trucks will actually go ahead and change their color as well. Probably one of these trucks could be this one over here. Well, Robert Brown, I could just go ahead and click on that truck and see, okay, where exactly on the map is it? What's the latitude and longitude? Can I go ahead and give the driver a call? Well, of course I can. Can I go ahead and see the fuel gauge readings right now to go ahead and recommend if there is something that needs to be done? Or go ahead and see what's contained in the trailer as well. But what I'm more interested towards is, why is Robert Brown's truck showing up as red? What's going wrong over there? Because I don't think it's heading into a stormy region there. So let's go ahead and see what's going on. Well, this is his truck with all the various sensor points that we are currently tracking. And we're just showing you the ones that we can show. Actually, there are 100 sensor points that we are tracking for this particular machine learning prediction as well. And each of these sensor points can be clicked to see more information around. So I could just go ahead and see what the water temperature is like. It's going to pull up a snapshot from the HBase in such low latency, mind you. I am at a real-time dashboard right now. And in such low latency, it could pull up a snapshot for me to show you all of that data as well. If I could just go ahead and get into one of these sensors, well, it makes sense for me to actually see that information live. So I have that as a live dashboard, which is being pulled up from an HBase cluster as well. So as I mentioned, sensor events going up onto event hubs, getting into Storm, calling machine learning, aggregating that information, getting stored into a low latency store like HBase, and being queried over here in such low latency time. That's the magic of Azure, and that's what we call the end-to-end big data analytics solution. Now, I was interested in looking at some more information as well. So if I'm looking at real-time data, well, look at the data hub. That's getting updated with real data right now. Look at the real-time data gauges over there. They're getting updated as soon as we get some sensor information coming in from there as well. In addition to that, I've also been able to hook it on to a driver dashboard. So I can now go ahead and see what a driver report looks like. This could be coming in from a third-party application. I'm not worried about it. This could be something that one of my other agencies manages. I could just pull that information back in here. And again, I could go ahead and track the truck right to the dot by plotting the latitude and longitude on the map right now. But what I'm interested towards is, okay, why is it showing up as red? And why is only the fish showing up as red and not the other components over there? Well, it is actually because the trailer cooling unit has got a prediction from machine learning right now. Machine learning sees that there is a pattern with the fan speed in the cooling unit, and it predicts that in the next 4 hours, or probably in the next 2 hours, as I see over here, the fan speed is going to come down to 0. As a result of the fan speed coming down to 0, the cooling unit's temperature is going to rise above the threshold. Well, that's a point of concern. Now, I have fish for sushi in that truck, temperature sensitive. It's going to get spoiled. And that's what machine learning predicts for me over here. In the trailer, it knows what are the kind of products that I have in that trailer. And it's predicting which out of those products is going to get spoiled, and all this in real time. And it also knows that there is some other types of products in the trailer, such as canned foods or some vegetable produce, which is not so temperature sensitive, and it will not get spoiled. So it's showing that as green. Now, I need to take some action against it, don't I? Just getting that information doesn't really make sense. So I can actually go ahead and create a task on this. Well, before I take into action any of the factors, I need to make sure that the sensor point is sending me the right information. For that, I need some anomaly detection happening on that sensor point. Now, if I had the sensor giving me some random values, in the current predictions graph, I would have seen some spikes up and down over here. Whereas, I'm getting a prediction of a gradual increase, which says, my sensors are perfectly fine. You're getting the right sensor readings. You are going to have your freight spoiled. Go take action. In addition to just doing some anomaly analysis, I also need to go see some impacted cargo. Well, what if fish for sushi was just like $1,000 out of $100,000 worth of freight in the truck? I don't want $99,000 to reach its destination late just because I lose $1,000. I can take a call on that. But here, I see fish actually comprises $50,000 out of the $60,000 worth of freight in the truck, which warrants me to definitely take some action right now. And how do I go about taking that action? Well, all in the app. I can go ahead and create a ticket. I can go ahead and divert the driver to either the nearest depot or to the nearest cold storage where they can go ahead and store it before the fish gets spoiled. I can go ahead and alert the depot that, okay, there is a new truck coming in. This is the problem. Prepare for predictive maintenance right now. And then go ahead and mark the job as completed. Well, the driver could have simply got a dashboard on their phones sitting like just the one I have on mine right now. And I've integrated Cortana to read out any instructions that I give out of this app to the driver so that the driver doesn't need to go ahead and divert his attention from the road and actually can go ahead and take the instructions as they come. I could just go ahead and confirm and notify the driver from here, and the notification flows back to the driver's dashboard as well. Once the driver's gone ahead and accepted that notification, I can go ahead and see back on the map now, Robert Brown's truck, which was actually showing up as red, has now gone to show up as green. Why is that? Well, I sent instructions to Robert Brown to go get that truck into a depot. Machine learning now knows that I've taken action against it. Machine learning also understands that the freight contained in the truck is no longer getting spoiled. And it doesn't want anybody else in the control unit to take multiple action against it. So machine learning now predicts that it's all fine. If there's anything else that's going wrong, or the diverted route that you've given, if there is a traffic snarl in there, I'll go ahead and mark that as red again. Okay? Now that's an end-to-end solution that you can build with such real-time technologies, with the likes of Storm, with the likes of Edgebase, with the likes of a Windows 8 dashboard that we're looking at within an app. And in addition to that, I also have an operational dashboard sitting on top of this. So let's just go ahead and pull up the Power BI dashboard up here. Well, somebody at a higher level in the organization wants to go ahead and see all the information at a glance. I have my Power BI dashboard to give them that view. I can go ahead and give them a drill down view of all the data in here as well. I could get into weather and traffic alerts over the period of time and show them a drill down report in there to give them a one picture view of all the data that's there. I can slice and dice. I can go ahead and see what's more interesting to them to go ahead and give them a better view or a higher level view of all the data in here. And in addition to that, I can also have all the real-time capabilities being drawn up on this particular dashboard as well as they were being done with Assad's dashboard in the real-time Power BI extracts. Okay? So that's kind of the end-to-end capabilities that we wanted to drive in this particular session. We started off very significantly with a data DVR example, a very simple streaming example. We dived into an IoT dashboard creation. Assad dived really deep into each of those templates, into each of those components. We created Spouts Live, we created Bolts Live, we hooked them on. We brought them onto a Power BI dashboard as well. And then we went on to show you a finished solution like the fleet management app, over here, which actually converted all the insights and information that was coming in into actionable tasks that could be created to save businesses thousands or even millions of dollars over a period of time.
And if you look at it, like basically, are you sharing the code for this one as?
Absolutely.
Yeah, so basically we will share the code for this Finish app as well. And one thing you will notice is that the code is not that different. Like beside adding a bolt for like machine learning to go and send the data and get the predictions back, and the number of sensors just went from one temperature sensors that we used in building the solution right now to many, many other sensors which were simulated that they are on the truck. That plus the dashboarding, of course, became much more richer using much more other features which are in the Power BI and for building your Windows 8 app. But pretty much the solution which we built, like you can build the solution at least for the initial thing very, very quickly, because the key thing is that you can go and deploy your Storm cluster, your H-based clusters, your machine learning models, all in matters of minutes. Like you can, in 10 minutes, 15 minutes, you can have all those clusters up, and then you can go and use all the libraries that we have written or the samples that we will publish to go and build the whole thing. And very quickly you can take a demo app and convert it into a more production ready with the rich dashboards that can give you a much richer and insightful information about your business.
Well, I think what we have up on screen is just the few lines of code that I've used to go ahead and call an ML API within one of the bolts within Storm as well. So if you were wondering, how does ML integrate into all of this real-time capabilities? Well, one of the bolts is actually passing every tuple that came in for those event sensors and calling a machine learning model API service and getting a response back and storing them back to the edge-based clusters, which is then being queried from the real-time dashboards. Okay? So, well, I think enough serious stuff. Let's get to some fun stuff. I have a lot of T-shirts lying around with me still. So, questions? Go ahead. Any questions?
You showed the real-time dashboard.
Yep.
What tool did you use?
That was a Windows 8 app. It was a custom Windows 8 app, which was just plotting the data points as they came in. With,
Do that with Power BI.
we can do that with Power BI.
Is it ready to be done with Power BI?
Yes. Yes.
Can I get a T-shirt?
Yes, you can. Was it just for the T-shirt? Question.
Did you do any distinction between Storm and Stream Analytics?
Yes. So currently the capabilities within Stream Analytics and Storm, and that's a very good question, it is pretty similar. Whereas we have Stream Analytics, which is a little more abstracted. You can write SQL-like code to do those operations. With Storm, it's more extendable and scalable. And that's why the title of this session was Scalable Real-Time Analytics for the Internet of Things. So again, from a scale perspective, it really depends on what are the number of events that are coming in, what is the kind of throughput that you want out of a real-time solution. And that would help you choose whether you want to go in with the open source Storm clusters on HD Insight, or whether you want to go with a first level managed service like Azure Stream Analytics. And both of them are the best in their regards. Okay? Yep, you get a T-shirt. Okay, so the T-shirts are getting the questions, not me. Right. Go ahead.
So in addition to this lead management, so you got any other, the industry solutions like, the home automation or the patient sensor management?
Yes, we have. We're currently working on 3 other solutions similar to the fleet management. One is a retail, one is a patient management, and one is a fraud detection for financial analytics. So these are 3 solutions that we'll have very soon available, and we'll probably kind of create some fuss or on Twitter or blog about it as soon as they are ready to be published. But currently, this one's all set. Probably will be going out next week via one of the blogs. Absolutely. We'll make sure everything is downloadable. Question? Yep. It's here for you. Yep. I don't. I have an. Yeah, just small. Yeah. We're actually working with some of the hardware vendors to actually do that automatically, like how do they create those gateways to get those sensor events right onto something like an event hub, or even onto some of the open source platforms like Kafka, etc. And we're working with some hardware vendors to make that happen. As part of Microsoft, that won't come as a service that you can deploy on those individual sensors or individual machines. It will be part of those machines as they roll out. Does that make sense? Yep. Yeah. Yep. That's all right. Yeah, go ahead.
These spots and poles you call them, right?
Yes?
Are they executed each time an event, a message enters into an event hub?
So these contain a set of code. A spout contains a set of code which is actually transferring that event from, let's say, an event hub to Storm. And then the bolts actually contain the business logic that needs to be executed on those individual events. So yes, every tuple of event is actually going through the spouts and the bolts.
Basically, there is a method in the spout which is next tuple. It keeps getting you the next tuple, and then there is an execute method in every bolt, and on every tuple it will call execute.
T-shirts. Yep, go ahead.
Today we're using Orleans doing this. Have you made any comparisons for how much consumption you're using HD Insight versus Orleans? It's a good way of doing it.
Yeah, we should talk about that in a little more detail. That's not such a short answer. Yeah, yeah. Yeah, sure. So it was all the T-shirt. Yep. I have some more gifts, so don't worry. I have a few 8 gig Azure HD Insight USB drives as well. So go ahead, fire in your questions, and for the people who are walking out, please take a survey. It'll really help us out. Give us high scores so that we can end up again. Okay? Yep. The next question gets that. I have this in my hand right now. Okay. Is that really a after-session question? That's more like a consulting question that you're asking me right here, aren't you? Well, the short answer to that is this is complementary. This is not a replacement. So everything's going to come in. If you look at the big picture, the data platform from Microsoft, each of those pieces has been put in place for a specialized task in there. So if you look at SQL Server, if you look at the Azure SQL Data Warehouse, if you look at stream analytics and machine learning, and then you look at the big data offerings that we have within HD Insight, all of that is actually a small part of the larger picture that we are trying to frame up. Now, we actually have a very good slide which explains that end to end as well. And we'd love to have that discussion with you in a little more details. Yep. Here you go. You wanted this one, right? Good catch, yeah.
How do you position AML compared to IBM PM and Q?
Well, both of them are very different products. When we look at it from the ease of use as well as from the kind of capabilities required to work with each of those products, they are in a different category altogether. One is meant for data scientists, one is meant for data professionals who are proficient or at least kind of understand the world of data science. Like, you don't need to go create regression algorithms. You don't need to go create, let's say, some more predictive analytics custom models around it. Here you can use things as they come. And in addition to that, we have capabilities like Marketplace, where you can just get services or get models that have already been published by data scientists or data professionals, and it can be employed over here. Yeah? Here you go. That's a very good question. I'll leave that to Asad. Asad, how about encryption?
Say that again, sorry?
Do you store encrypted data in the HBase database?
So basically, if you have the
encrypt as you are writing it out.
So you need to encrypt before store and then encrypt.
It depends, like what, like are you using encryption on RAM or are you using encryption as when the data is moving and you are writing? So when it comes to the Storm thing, basically it allows you to add the third-party libraries for encrypting data and doing anything you want. For specifically for HBase, I don't know the inbuilt capability.
Okay, final question here. I promised you the headphones for anybody who can answer all the various services that we talked about. And I see we have very little competition here as well. So the first one to put up their hands, except for that guy. He's already got one. We come to you last if nobody can answer. Go ahead.
Event Hub,
Okay.
Storm,
Okay.
Hadoop,
Okay.
HBase,
Okay.
DocumentDB,
Okay.
SQL Server,
Okay. You lost it. Next.
YAML.
Okay. Still short. Go.
HD Insight, Power BI, Apache Storm, and I'll start over basically he said Event Hub, SQL Azure, DocumentDB, Power BI we already did it, Event Hub, and then HBase,
You did it.
I think it.
Who else? Come on. Go ahead.
HDFS site, Azure ML, Storm, Power BI, Event Hub, HBase,
Okay.
Azure ML.
Okay. There's one more. Come on. Come on. Go more. You already mentioned Edgebase twice, so yep. Go ahead. Anybody else? You're still missing one technology.
Azure, HBase, Project Storm, HD Insight, DocumentDB, Event Hubs, Power BI,
Hive we do not use. Okay. I'm going to go back to my man there. Go ahead. Awesome.
Can I get a gift?
Yeah?
Can I get a gift?
Oh, yeah, sure. Please. Here you go. All the folks who